Okay, we have derivative of inverse hyperbolic functions, and then we've been given here if y equals to the sine inverse of x, find dy dx. Solution. So the first thing is for us to write this hyperbolic, to write this hyperbolic statement as a direct statement, in that when you have y equals to the sine inverse of x, then it means that x equals to sine y. We write it as a direct statement. X equals to sine y. Therefore, we differentiate this equation with respect to y. So we get dy, we get dx, dx, dy. So when you get dx, dy here, it is equal to cos y. It equals to cos y. So this is dx, dy equals to cos x. But again, when we are getting the derivative, it's always changing y over changing x, but this one is changing over x all over changing in y. Therefore, we get the reciprocal of this, which will be dy dx, then it will be equal to 1 over cos, 1 over cos y. Now, from the fundamental identity, we know that cos y squared plus sin y squared equals to 1 from the fundamental identity. Therefore, we want to express this cos y in terms of sine, so that this cos y squared then equals to 1 minus sine y squared. But here we are saying that x equals to sine y. Therefore, we replace this by x. So this equals to 1 minus now x squared. But it's cos y squared is equals to 1 minus x squared. Therefore, cos y, we get the square root on both sides. Therefore, cos x equals to the root of 1 minus x squared. So this is cos x. Therefore, we can replace cos x in this statement. Therefore, we can say dy dx equals to, it will be now 1 over the root of 1 minus x squared. That is it. So the derivative, so what we are saying is, therefore, if y equals to sine inverse of x, then dy dx equals to 1 over the root of 1 minus x squared. Thank you.